Okay, let's get started with our compound interest work by having a look at just some of the basics behind compound interest and introducing you to the terminology as well.
So compound interest means that interest is calculated on the previous interest amounts as well as the principal. So every so often, on a regular basis, we'll stop, calculate how much interest has been earned so far, and add that into the principal, and use that new bigger principal amount as we carry forward for the next time period. We tend to use compound interest when we're dealing with things longer than a year. So it's very common, of course, in finance. And it also becomes sort of the heart of our future formulas we're going to learn in subsequent chapters as well. So we're going to use this quite a bit over the next few months. Let's have a look at the effect of compounding. I took $1,000 and I just said, let's invest that at some different rates here and see what we're going to end up with. And I used a compound rate and I compounded monthly. So what that means is every month we'll stop, work out any interest that's been accumulated, add it to the principal, and then for the next month keep going with a new bigger principal, and so on and so on. So it keeps growing and growing as we go. Let's have a look. If we went in for 5 years at 6%, we end up with $1,349. Now with simple interest, we would have had $1,300 exactly. So you can see we made a little bit more money than we would have with simple interest, and that's because interest is also earning interest, so it's starting to make a difference. What if I doubled the time? So let's look at 10 years now. Well, if I double the time, I end up with 1819. So if I'm thinking of just the interest part only, if I take out the original 1,000, I've got more than double, don't I? Because double 349, that would be 698. So I've got more than double the amount of interest by doubling the time. That wasn't true with simple interest. When you doubled the time, you simply doubled the interest, didn't you? In this case, it's actually growing at an exponential rate. So we're going to end up with more interest as we go over time. You can really see that if you scroll down or look down all the way to the bottom here with me. 50 years. So if I go 10 times the original 5 years, I've made 18,936 in interest on top of my original 1,000 for a total of 19,936. That's a lot more than the 349 and much more than 10 times, isn't it? So it really takes off over time. Time is very powerful with compound interest. Part of the reason why financial planners are always trying to talk to young people saying, look, if you start working on your retirement plan now, you're going to be a very wealthy person by the time you retire. And there's some truth to that because time has a very big impact on the results when we're using compound interest. What if we look instead at doubling the rate? So I go over here and I've got 12%. Well, again, notice the same thing happened. Instead of 349, I made 817. So again, more than double the amount of interest. And look at this one. This is really impressive. If we could earn 12% consistently for 50 years, $1,000 without touching it ever again, just letting it sit and grow, would turn into nearly $400,000. That's impressive. If only we could find 12%, and if only we were smart enough to maybe invest that money when we were 10 years old so we could take it out when we were 60. But it really does show you kind of the power of compounding. Here's a graph of those same numbers I had on the previous slide here for you. This is if we use 6%. This was the line for 8%. I had one in there for 10%, and then finally 12. So you notice two things on this graph. They're all fairly similar at the beginning, but as time goes along, the differences really start to appear, and that's because your interest has had some time to really start to go to work for you. And as the rates increase, we also really notice an exaggerated difference as well. Let's say, for example, you were earning 10% on your investments. And with just a little more work, you could have earned 12. And you think, well, what big deal is 2% really? That's only going to give me, a 20% boost if I look at 2 compared to 10. It doesn't, does it? It's actually much more impressive than that. You more than doubled your results. So it gave you much more than you would have got, which is 10%. So sometimes that little extra percent, if you can earn 1% or 0.5% extra on your investments, it's going to give you much more than that in return later on in life. That's a fundamental thing a lot of people don't understand. And so they may go and set up some investments at their bank, for example, and they may not really be too concerned whether they're making 5% or 5.5%. But that extra 0.5 will make a big difference over time. So you really do want to pay attention to things like that. That's one tip right now. If you take that and remember that from this course, it could make you much wealthier by the time you retire. All right, let's have a look at our notation now. We're going to use a new set of notation because we don't want to mix it up with the simple interest notation we already have. So I'm going to use PV for present value. We just used to use P there, didn't we? And we use PV. I'm going to use FV for the maturity or the future value. That kind of makes sense this time, and that's kind of like our old version of S when we had simple interest. So when it's compound, we'll call it FV. N is the number of interest periods. That's kind of our notion of time. It's not measured in years though anymore. It's measured in how many compounding periods we're going to get. So if I were to compound twice a year for 5 years, there would be 10 opportunities to compound my money. N would represent, or be 10 in that case. M is the number of interest periods as well, but it's just the number per year. So it's kind of our base number we can use to work out N. So if I said twice a year, M would be 2. And if I did an investment for 5 years, N would then be 10. So M and N are similar, but one's just for a year, one's for the whole investment period or question that we're dealing with. There's another variable now we're going to use, and that's J, and that's similar to our interest rate. It's the annual rate as well, but this time it's compounded. And to tell us that, we're going to take this little m and we're going to write it down beside here typically. So if something was compounded 12 times a year, I would just put a little 12 beside it. And that kind of replaces our notion of R, but it's a nice format for us to use because it not only tells us a rate, but also how often something is compounded. So it gives us the M as well. And then finally, we often also need to know not just the rate per year, but how much per one period. And that's called little I, right? That's the one we usually work with. And so I is just the annual rate divided by how many times per year we're compounding. So for example, if I was doing, let's say 8% compounded quarterly, well then I would divide that by 4, and I would get 2% every 3 months, 4 times a year, for a total of 8 at the end. I'm going to show you a bunch more examples of that just to make sure that you understand those. So let's clear the screen and have a look at those. Let's look at an example maybe where I invest for, let's say, 10 years at a rate of, and then I'm going to put in a bunch of different ones. All right, so let's have a look. So if I said, okay, my J, my rate here, is going to be 10%, and my M is going to be 2. That's a semi-annual rate, isn't it? And so I'm compounding twice a year in that case, so that's 5% every 6 months, or 10 in total. So if I look at that, then my little I would be 5%, or 0.05. What would N be? Can you think about that? Let's see. So I'm in there for 10 years, and I'm compounding twice a year. I'll get 20 opportunities or 20 compounding periods in that question. Let's look at another example. Let's put in a rate now instead of 6%. Compounded 12 times a year. That's a common one, and that means compounded monthly. All right, so we're going to compound monthly. 6% for the whole year. If I compound once every month, I got to divide that by 12 to get little I. 6% over 12, that's 0.5%. So 0.005 or 0.5%, whichever format we want to write it in. What's N going to be this time? Well, I'm in there for 10 years, but 12 times a year means I'm in at 120 compounding periods or 120 months. That's the idea behind J, M, N, and I. It's not a bad idea now to go to the first section in our textbook and practice a bunch of these before you keep going with the formulas and starting to work with the problems, just to make sure this is almost automatic for you and you've really got it down. But just like before, take your time when you're going through these questions, especially at first. Think about, all those little things like J and M and N and I. Make sure you get those organized, and it's worth spending a little extra time practicing that now because we're going to use that really for the rest of the course, so you really want to get good at that. Let's make sure we're working in consistent units. So if the rate's compounded monthly, we're going to use months for the periods. If the rate's compounded annually, we'll use years. If the rate's compounded quarterly or 4 times a year, we're going to work in quarters. There's not a lot of different compounding ones, is there? There's annual, semi-annual, quarterly, monthly. You may see weekly, daily. Those would be the big ones. There may be a few others that come up from time to time, but those are the big ones. So you typically, be working on one of those. You'll get used to them real quick. Again, just practice a little bit before you go too far. Use all your decimals during calculations. Never don't round until you get to your final answer. That's typically the best way to go for us, unless there's a specific reason around part way. But otherwise, try to work within your calculator and get good at doing that. That's it for now. Have a go with some of these, practice through this section of your text, and I'll see you next time.